Hey everyone, and welcome back to this class, Deep Reinforcement Learning, Deep Learning in Python Part 7. In this lecture, we are going to do a tutorial on the basics of OpenAI Gym. At this point, I'm assuming you've already installed it using the instructions from the Where to Get the Code lecture. What we're going to do in this lecture is connect to an environment and play an episode using just random actions. There won't be any learning in this lecture because all we want to do is familiarize ourselves with the API and figure out where all the stuff we need to do learning, like states, actions, and rewards, can be found. If you want to see this code all at once, the relevant file in the course repo is gymtutorial.py. The first thing you'll have to do, of course, is import Gym. If this fails, that means you haven't installed the Gym properly. The next thing you want to do is get your environment. This is the gym.make function. Notice how in this example we're getting the cart pole environment. As you know, cart pole is the environment where the task is to balance a pole on a cart. Of course, Gym has other environments as well. One way to get a full list of environments is to simply go to their website and click on the link Environments. That will take you to this URL. Each environment page has a short blurb that explains what the task is and whether or not the environment has been solved, and a leaderboard, but not much more. Documentation is generally pretty sparse, but more on that later. Now that we have an environment, we want to run an episode, so let's do that. The first thing we need to do before we start the episode is we run the reset function. This puts you into the start state. If you do this in your IPython window, you'll notice that this returns something. It's an array. Well, what's in this array? It looks like an array of 4 floating point numbers. This, as you might naturally guess, is the start state. Now you might be wondering, well, what is the physical meaning of these numbers? For this, the documentation is a little sparse, but luckily for the first 2 environments we'll be looking at, this information is available on the wiki, which is strangely not linked from the environment page at openai.com. The Cartpole wiki can be found at this URL on GitHub, and from there you can find links to other wiki pages as well. What you'll see is that the 4 numbers represent the cart position, cart velocity, pole angle, and pole velocity. You can also get the min and max values. Now, of course, none of these URLs you have to type out manually. You can copy and paste them from the Python script. You can also get some of this information from the console as well. If you do env.observation_, you'll get back an object that says box4. Let's assign this to a variable called box. If you type in box dot and then you hit tab, you can see a list of attributes and functions you can call. You can call the contains function to check if a vector is part of the observation space. You can look at high and low to see the maximum and minimum values that each element can contain. You can also grab a sample from the state space, which can be useful. While we're doing this, we should look at the action space too, which behaves similarly. If you look at the wiki, you'll see that there are 2 possible actions: push the cart to the left or push the cart to the right. This makes the problem a little easier than the full cart pole problem, where you have to model the force as a continuous variable. In the console, you can type in env.actionspace and see that this returns a discrete object with the parameter 2. If you type in env.actionspace and hit tab, you can see again some functions and attributes that a discrete object has. Again, we have the contains method and the sample method, and there's an attribute called n that tells us how many actions are in the action space. Actions are always numbered from 0 and up, just like how we treat classes in supervised learning. We are finally ready to start playing an episode. Now that we know what the states and actions are, how do we perform an action that will give us a reward and the next state? The function we're interested in is env.step. It takes in 1 parameter, the action, and returns 4 values: the observation, the reward, a done flag, and an info dictionary. We usually ignore the info dictionary since it's for debugging. It can contain useful information to help your agent learn, but as per the rules of OpenAI Gym, you are not allowed to use this in your submissions. Because we're not doing any learning in this lecture, we can simply sample random actions until the episode is over. This loop would look like this. This will most likely end pretty quickly because doing random actions won't keep the poll up for long. As an exercise, you may want to add a counter to see how many steps, on average, are completed before the episode is over when you only do random actions. This can act sort of as a benchmark to compare your later algorithms.